Hello to the second live talk webinar of K-RTLS Solutions. Today I'd like to talk with you about our campaign, our RTLS campaign, and especially about our RTLS UWB system. And I'm very happy to have a very valuable colleague at my side, Michael Kaiser. Michael, please.
Hello, Thomas. And a very warm welcome from my side. I'm Michael Kaiser, Director for Product Management at K-RTLS Solutions.
I think we take a seat so it's a little bit comfortable. Yeah, Michael, the first question is, what was the initial idea of K-RTLS Solutions to develop our own RTLS system, and especially why UWB based?
Yeah, so let's start with RFID. You know from our RFID system that is perfect for identifying of goods and containers. And that's why you can identify the position of reading. With our system, you can also detect the direction of movements, so you see it goes in or goes out, and this is the base for to digitalize and visualize processes. With RTLS, it's more and more requested to identify the exact position, and that's why we decide to choose an RTLS system to localize. And ultra-wideband is the reason because also on the one side it's standardized. So this is very helpful if you go to industrial environment, that this is a standardized system. And on the other side, it's very, very precise and very, very flexible.
Second question, Michael, is to give our audience an impression what kind of projects are possible UWB based, maybe in material flow or especially production flow areas.
Yeah, as I said, with RFID you can identify very well. With RTLS you can do much more. The point is you can localize the exact position. For example, you are on the production side and you have a machine and you have some material. With ultra-wideband you know exactly is it on the left or on the right side in front of the machine. But you can also use it to combine tools and containers. So if you have a production running and it's very necessary that a certain tool is close to this material, then you can combine this information, you can read out this information and combine it. You are quite sure this is the right combination of tools and containers. And last but not least, you can use it also for forklifts, you can use it also for other automatically guided vehicles, driving around in your production site, driving around in your warehouse to identify where are my forklifts going, to identify on the one side for security reason, you see exactly where are my hotspots and I have to take care for this. And on the other side, you can optimize the efficiency to see what is the shortest way, what is the best way to move your goods in the warehouse, for example.
I think forklifts is a really good example because we just do some tests in our test and service center to figure out what benefits we can create or win when we combined RFID identification on a forklift in combination with RTLS systems. Maybe you can explain something about that.
Exactly. So the point is, as I said before, with RFID it's possible to identify the movements. You see goes in or goes out. This is very helpful. You have to tag all your containers and then you can identify where the goods are moving. Yeah? With RTLS, of course, you can do it in the same way that you tag the goods with the transponders. But it is not a transponder, it's an active transmitting system, and then you can see all the goods are moving. But it's a question of the return of investment because this active system is a little bit more expensive than RFID, but you can change the process because then it's possible to tag the forklift, to tag the guided vehicle, and to identify the position by this. So the container will be tagged by RFID, the position will be detected by ultra-wideband, and though you can combine this information, and this gives you a very good return of investment because you can optimize your system, you can get the position and can get the identification with the best system.
Thank you, Michael. Very interesting. So let's talk about our RTLS system itself. What kind of components are necessary to get a functional installation of our system?
Okay, so let's start with a node, with the anchor. This device is mounted fixed in the building or on the ceiling to get the position of starting. This means with this information we can build up a grid in this area, and based on this you can identify. A short example to explain this in detail. For example, you have a small lake, a small pond, you throw a stone in the middle of the pond and you measure the traveling time of the waves. When you come to the edge, you can measure it and you can see how far the stone was away. If it's placed in the middle of the pond, the traveling time to all the edges, to all the anchor points will be similar, the same. If you are closer to one end of the pond and you throw the stone, the traveling time will be here shorter, and on the opposite side it will take longer. The same we do here with the nodes. The nodes are mounted fixed on the ceiling. You have the exact position, and based on this grid you can identify where are my goods. These nodes we have in different versions. This is the standard version for indoor use. We have standard RJ45, we have a standard DC connector and can use it in indoor. We have the same unit also with an M12 connector for IP67 for outdoor use, for rain and snow. This can be used for outdoors. One point for the Ethernet. This Ethernet can be used for data transmission, but also for power supply. We have added PoE, power over Ethernet, with this device, and though we can use it also with one cable, with a Ethernet cable to supply these devices. An additional feature we have with this device is that we can use this node as a transponder also. Yes, this means we can switch to a transponder mode. This gives you two advantages. One advantage is that you can measure this position of the nodes to the other positions. This is helpful for the service. And on the other side, you can use this as a permanently supplied device on a forklift, for example.
Thank you, Michael. So let's talk about a bit about the backbone possibilities, because we have Ethernet and wireless LAN.
Yeah, so we have, as I said, the Ethernet connection to connect the device directly. But in some cases, if it's necessary, we can use also a 2.45 gigahertz system in parallel to get a service use. So this means we can get access to this device. We can do a software update, we can read out some configuration and so on. But you can also use it as an additional node to combine this node to an existing group. Yeah, this runs with 2.45 gigahertz, it's Wi-Fi, and the ultra-wideband system itself runs around about 6 gigahertz.
So I think one of our USPs of our system is that we have 3 modes.
Yeah.
So why we have 3 modes, and what are the difference between the modes?
Yeah, as I said, more and more it gets important to know the exact position of the devices. That's why the first mode what we have is the time of flight mode. It's a very precise mode. The accuracy is around about 25 centimeters. You know exactly the position of my goods, of my containers, very, very precise. On the other side, we got more and more the request also to get in a dynamical mode. In this case, we can tag, for example, a forklift. The forklift is moving, and maybe the exact position, the precise position is not so necessary. I want to have a very fast feedback to go exactly to follow exactly the way of the forklift. In this case, we have a dynamical mode, called time difference of arrival. I measure my system much faster, and I can get a very fast feedback from the system where is my forklift. These both modes are allowed indoors. For outdoors, there are some rules that, for example, direct radio should be protected. We are working in the same frequency range as direct radio systems, and that's why it's not allowed to use this time of flight and time difference of arrival mode outdoors. For this mode, for this use case, we have developed a system called angle of arrival. With this angle of arrival mode, we can identify the transponders based on the angle information. We know exactly from which angle the signal arrives, and this is allowed outdoors, and so we can use these 3 modes, the outdoor mode, the indoor mode, very dynamically. So we can, based on this application, we can use it indoor in an area where we need a very high precise position. We can use dynamically when it's go to a warehouse and we will follow the forklift, and we can use it outdoors to identify where are my goods outdoors. The good news for you is you can use it seamless. This means you can have one transponder running to all these areas, running to all these use cases, and you don't have to reconfigure, you don't have to change something in your software. Based on the existing groups and the existing areas, you get the feedback very precise, very dynamically, or for outdoor use cases.
Sounds very interesting, Michael. Thank you. So let's talk about the transponder. Maybe you.
Yeah.
So maybe at first to give our audience an impression about the dimension, maybe we put this one together so you get an idea how big it is. And yeah, Michael, what are of specifics we have with our transponders?
Yeah. So as I said, the nodes are based on your grids. This is the anchors mounted in the building in these areas to build up the grid, and you know exactly where are my anchor points. And based on this information, the transponders are traveling around. And first of all, I want to show you some mechanical feature. The point is that we can use this sledge single, so we can mount this sledge on a container or on a container. And each time you need the transponder, you can add this very easily with a click. So you can marry your process, you have a starting point, and from this point on you can use it. This helps you to be more flexible. Based on the transponder, as I said, it gives you the information about the traveling time of the signals. We send out signals, and this will be recognized, will be received from the nodes. In this case, we have ultra-wideband to identify this based on the 3 modes. But we have also added some additional feature here. So we have ultra-wideband for the localization, but we have still RFID for the identification. There's an RFID transponder built in UHF. So based on your existing RFID process, you can use also this transponder and can start on the right point. This means you don't have to change your complete infrastructure to RTLS, because it's enough to have a special area where you need this precision, where you need this localization, and in this case you can add this transponder. Before and after you can use still your RFID process, and you can save your invested money. Yeah. In addition, we have also NFC. NFC gives you the possibility to visualize something. This means we can read out data with any mobile phone, we can read data with any tablet. And now the good news for you, all these 3 services, ultra-wideband, RFID, and NFC, are combined by I2C bus. This means I can write down something by RFID and I can read out by NFC. I can write down something by NFC and I can read out by RTLS. This makes the system very, very flexible, and I can add a lot of additional features, a lot of additional function to the system.
The LEDs on the transponder is maybe also an important point.
Yes, there's a multicolor LED which gives you the information when the system is starting, when the system is communicating, in kind of errors, and so you recognize this, and you will be guided by this. One additional thing for the power supply, we have here a standard battery included, CR123A. You can replace by your own, you can open this device, you can remove the battery, you can add a new one, so it's quite easy to run this. This is very seldom, because the battery lifetime will be between 1.5 for the high dynamic mode and around about 5 years for the other modes. This means in standard you have around about 3 years when you have to replace the batteries, but you can do it by yourself, and it's quite easy to do.
The USP or the difference from our transponder when you compare to competitor systems is that we have 3 technology on board. Let's talk about that.
Yeah, as I said, we have this NFC, we have this RFID, and we have this ultra-wideband. This gives you the chance to start with existing RFID processes. So you have RFID already used, you have some RFID systems running, and with all of this RFID system, you can read immediately this transponder. We can combine this information by I2C bus between the RFID part and the RTLS part. This gives you the same data structure. So you can use existing processes, you can use existing infrastructure. Yeah, so all the spent money, all the money you have spent already for this infrastructure will be continuously used. Yeah, so you don't have to start from scratch with a new system. You can add it where you need it. And last but not least, we have NFC for visualization. You can use your mobile, you tap on, you can read out the data. For example, if you have a changing process, some material will be removed, some additional parts will be added, and then you can do it on site directly with a mobile, with NFC, and you can change this data. So very, very flexible and very, very dynamic.
Sounds very interesting.
Yeah.
So far about our RTLS system itself. Let's talk about our RTLS campaign. We, Katrin, have created or calculate a really aggressive price for a test and demo kit, because we like to give you the opportunity, our partners, the opportunity to install their own test and demo environment, because it's very important, I think, at discussion with your customers. That's not only to talk about RFID, maybe also to talk about a combination of RFID and RTLS, and that's maybe the step ahead in front of maybe your competitors. Michael, let's talk about the components of our RTLS demo kit. What is all included?
Yeah, as I've already said, the nodes are included, the transponders are included, they can handle this, including the batteries. It's also included a mechanical possibility to mount the nodes with a 3D mounting kit. We have also added a switch, a PoE switch, so you can connect all the nodes directly. You can supply all the nodes with Ethernet cable. Of course, the Ethernet cable itself is also combined. You can connect it quite easily, and that's why it's quite simple to install the system by yourself. In addition to all this hardware, we have also added software to this system. And the first I will start with is the RTLS Wizard. The RTLS Wizard is a software to guide you for the first steps, to guide you to explain what is RTLS working, how is it in the installation. Step by step you will be guided to install the nodes, to install the transponder, to build up your grid, to add, for example, a picture of the room, of the area you want to use. And step by step you will be guided up to these 3 modes I explained before: the high dynamical mode, the high precise mode, and the auto mode, that you can use this and you can learn from scratch how the system is running.
So you doesn't need any experience with RTLS systems when you use the Wizard.
Exactly. With this Wizard, you can start really as a bloody beginner, that you see a guideline, how to connect the devices, how to switch on. It will be step by step, and within, let me say, 20 minutes, half an hour, you will be guided to install the system the first time. And based on this, you can make your own experience. And the next step, the next software we have also added is the RTLS Start software. This is a software to parameterize the device. So when you have made your first tests and your first ideas, you can switch to the RTLS Start software to configure the system more detailed. You can read out data, you can do some change of the configuration if you want, and so on and so on. A lot of things are possible, more powerful with this.
But to make it clear, the difference between the Wizard and the RTLS Start is the Wizard is only for test and demo cases. Exactly. And the RTLS Start is when you do a real installation for maybe later for go live.
Exactly. So the Wizard is really for the beginning from scratch, that you know exactly how to install the system, what are the different modes doing, and what are the results. So in a very fast and easy way you will be guided. And the RTLS Start software gives you the chance to start with your first own implementation.
Thank you. So far about our RTLS systems, and especially about our RTLS campaign. Please remember, it's a very aggressive price. Take the chance, take the opportunity to do it. I have forgotten something?
Yeah, we have forgotten something. The most important thing, crosstalk.
Sorry.
Because the most software tools I explained before was to install the system, to test the system. But to run the system, we give also a software called Crosstalk. Crosstalk is a very powerful software environmental to run 24/7 the system, to collect the data, to transmit the data to your backend system, to exchange data, and so on. Yeah, based on the 3 modes I explained before, you can install the system, and the data will be collected and transmitted. This is a combined software suite, very powerful. This is also part of the demo kit. But I give you also another idea, that you can run your own software, you can develop your own software based on these 3 modes. We give you some detailed dynamic link libraries, DLLs, to develop the software by yourself. So you can do, based on your own capabilities or on your own knowledge, to build up an own software by yourself.
Very important. Thank you, therefore, Michael. Yeah, if you need any further information, we have created our own landing page on katrin-solution.com. So please don't hesitate to contact us also as well by phone if you need any more information about that. I don't want to forget to say something about our academy. I hope one of you still known our academy. It was especially for RFID trainings, but we have also a training program for our RTLS systems. If you need some training, if you like some training, please don't hesitate to contact us by email, by phone, and we will arrange a date for you for your own training. So far, Michael, I think there's no more to say as goodbye. Many thanks for your time, for the explanation about our RTLS systems. It was very interesting for me as well. So I hope it was also interesting for you. And goodbye from our side. Bye-bye.
Bye.